your unsupervised learning algorithm. So how one data set we can uh, take, and we can apply the k-means clustering algorithm for that, which will be your unlabeled data that we will see. First, let me share the screen. So are you able to see the screen?
You can check the comparison of the paper.
Is it visible?
Yeah, one table. No. Ours is more. Ours is more. By including the data. By what including the data?
Okay. Here, for just to give you an idea how we can use a particular data set for the prediction, I am using here the housing prices data set from Kaggle. So there you can find n number of data sets, and there you can take it and you can apply the various algorithms on those data sets, and you can do the prediction and develop your model. For that reason, I have taken to show you how we can use a particular data set and apply the k-means clustering algorithm. So as I have already this, told you in earlier class that here clusters or groups are different, distinct clusters or groups are formed in the k-means clustering algorithm. So based upon that clustering, the prediction will be done. So here also you can see in this Google Colab, I have used this from google.colab import files. So if I use this, then one upload widget will come where you can choose the file and use that file. Uh, in Jupyter Notebook, there is directly option where you can mention your uh, file path. From that path, the file will be automatically picked up. So in this Google Colab, we can directly use this kind of thing. Here I have downloaded this data housing.csv file where the data, different data is there. The basically the housing price data is there where the uh, heading longitude, latitude, and median house value will be there. So this already you know about longitude and latitude, how we can define one particular location. Based upon these only we can uh, get the location of that place. So directly we are using these three values. So here it is mentioned only longitude. So it is how far in the west direction the house is. So higher the value means the houses are at further west. Then similarly latitude is how far north a house is, and the higher value will represent how far in the north the house is, and the median house value is the house price within the block, which is measured in USD. So is here the values are in USD. So from this we can directly visualize our data. You can see. So using the seaborn we can directly visualize this, and we have applied here latitude and longitude in x and y coordinates. then the median house values will be in this way. So it is in range. We have define our data in range, which will be better for our understanding. So between this and this range, this much of data is there so that we can see. So here the ranges are defined here. So this we can visualize. So we can see these houses are scattered in different places, and the latitude and longitude for each of the location of the house is associated, which can be seen here. Then you can see we are just normalizing the data. So this is much important to normalize our data. So if we do not normalize the data, then the variables with the different scaling will be weighted differently in the distance formula, and this will be optimized during the training. So for example, if we have to include the price in the cluster, then in addition to the latitude and longitude, the price should have an impact on the optimization, because the scaling is significantly large and wider than the bounded location variables. So that's why we are normalizing our data here. On a scalar only, we can do this by using the pre-processing method. Then directly we are fitting and evaluating the model. Here we have taken a number of clusters equal to 3. So here we should take this number of clusters equal to 3, and the random state we have taken 0, so that the randomness we can control, and it will also ensure that the initialization of the cluster centroid, means the starting point, is consistent across different runs of the algorithm. Even though if we're running this algorithm for numerous times, so then it will be producing the same result. And then an init parameter we have used, which we have put it into auto. So how many times we run this k-means algorithm, so with different initialization of the centroid to find the optimal cluster we can get. Then after fitting the data, we can access the levels from the levels attribute with here you can see. So here 3 clusters I told you that we have divided. So first we will take the cluster 1, which will contain the data points that are geographically close to each other in terms of latitude and longitude. And the points in this cluster will be grouped together as they have similar values of latitude and longitude. So all these 3 clusters have close data points, geographically close data points, and but all the 3 clusters will be distinct from each other. So that's why we have put 3 clusters here. You can see here in color form, 0, 1, 2 in different colors. So these are located in a very nearby to each other. So that's why this clustering is done. So here in this k-means clustering, we generally don't know how many clusters we can prepare and how many clusters we can put all the data points. So that I will show you after this example, that we will be using range of that number of clusters instead of directly mentioning the number of clusters equal to 3. So I have told you about the centroids here. So each cluster will have the center point, which will represent the average location of the data points within that cluster. So this algorithm calculates the centroids based on the features, which are here are latitude and longitude. And the data point assignment is there. So here each data point is assigned to the cluster whose centroid is closest to it, which will be done based upon the Euclidean distance. So some mathematical things we have already seen in our last classes, so I will not go very much deeper into that. While you again applying this, you can refer to that also. So based upon that, here the clustering has been done. So after that, we will see here using Bloxplot, we have visualized this whole data. The 3 distinct groups are there: Northern California, Central California, and Southern California. So based upon that, the California housing prices data set we can clearly put into 3 distinct groups, which we can see in this box plot. So here you can see the northern and southern clusters have similar distributions of median house values, which are clusters 0 and 2, that are higher than the prices in the central cluster. So we are just evaluating the performance of the clustering algorithm using Silhouette score, so which is a part of the scalar matrix only. Means if we are getting this score lesser number, so then it will be a better fit. So here we are evaluating that score, and we are getting the score around 0.7499. So here we have seen how the number of clusters we have defined, and based upon that clusters, how we can put the whole data set. So I have told you that choosing the best number of clusters is not like this. And this is the main weakness of the k-means clustering, that we don't know how many clusters we need by just running the model. So we need to test the ranges of values for the clusters. So k equal to range 2 to 8 we are taking. So by we are just defining here. And first we will see at the value k equal to 2. So you can see these 2 clusters are there. So in this 2 cluster, the model is doing an okay job of splitting the state into 2 hubs, but it does not capture enough points in the California housing market. So now we will take the value of k equal to 4. So by taking k equal to 4, you can clearly see that the group is organized into logical clusters across the state. So this model captures more points in the housing market. So after that, we are taking the last range of value k equal to 7. So just a minute, I will run this. So directly it will not run. I have to run the code from the very beginning. So I was just running that. You can see here at 4, the 4 clusters will come, but at 7, more number of clusters will come from 0 to 6. So like that only it will come. If you just run this code one by one, then you can understand. So that will be more accurate for geoclustering. So you can say that as we increase the value of k, so we will see the improvements in the cluster. So like that, we have to put a range of clusters. Not directly, we are putting into some random number of clusters. So this particular line plot we are just putting. And you can see k equal to 5. Here. So it is the best at k equal to 5 without overfitting. So this you can see. Like that we can apply this k-means clustering algorithm. You can try with different data sets from Kaggle you can get. Here actually we are not doing till now we are not doing the clustering algorithms. We are just applying here the basic classifying algorithms. Along with that, we are doing the optimization, hyperparameter optimization that I already told you in the earlier class. So based upon that, we are using that for classifying the data if into two labels 0 and 1. So here it is directly, it is not labeled. We are just putting all the data we have into clusters, and we are just seeing how these clusters are associated and how we can predict our model. Hope you are able to understand it. You just try with different types of data sets, and basically the code will be like this only for this algorithm. You can try, and also if you can write into a very efficient way the code, then it is fine. The efficiency is very much needed for writing the code. So you can try. So any doubt till now? Here I have already only show you the k-means clustering. So like that can try with different unsupervised learning algorithms also. So we just take different models and we predict which model is giving the best. So like that we do in the machine learning. we cannot say that particular for if we are taking a data set and for particular model, the efficiency is this much, the accuracy is this much. So we have to analyze that by taking different models. After this, we will see the reinforcement learning.
It's so funny.
So now we will see the reinforcement learning.
So we have done only for the consequences, right? Right. So you do only one thing.
So this I have already explained you where the reinforcement learning there is agent is there, so which will be taking some actions to, and while doing the actions it will move from one state to another and finally it will reach the reward. So here I have just directly taken one example and I am just importing to show you the random gameplay in the Atari breakout game, so that you can see from this. I will show you the game. Or most of you have might played this game earlier. So here one ball is moving, so we have to catch this ball so that it will go and it will break these lines in different colors: blue, green, yellow. So one by one the ball will be broken by this ball, and if we are missing this ball then the score will be listen. You can see from the image, GIF image. This thing in the Python we can directly implement. So here we are using the Gymnasium, which is a toolkit for developing and testing reinforcement learning algorithm. So it directly gives us the predefined environment in Atari-like games. So this way we can implement. First we have to install all the modules, and this except ROM license we have to use it during installation so that we can use those to emulate the Atari games. So these Atari ROMs are not included in the Gymnasium by default as they are licensed. So that's why we have to accept this license and then we have to install and then we have to use it. Then we have to install this ALE. So it is the underlying emulator for the Atari games used by the Gymnasium. So this ALE will be used to emulate the behavior of the Atari console, which will allow the reinforcement learning agents to interact with the game.
Only one thing that I just want to know whether ours is more not in the number.
So this is your arcade learning environment in the Python interface, which is used by the Atari environments. By using all this, we can now use the emulator. So first we will create an instance of the breakout Atari game. Then we have to initialize the counter to track the number of steps taken, which is equals 0. Then we have to prepare the frames for entering.
Only that one. See, I don't want to
So
see
here the
numbers
frames
like that.
equal to
You will have
your parenthesis will
this, you will be letting
have a list to store the frames
after removing the
that is the images of the gameplay for creating an animation later into the later part, which I have already shown you at the beginning of this program.
So then I want to know whether this is coming more or less.
So
Our data is more or their data is
the flag
not in the terms of number.
done equal to false
Can be G.
is used to indicate whether the game has ended or not.
B is in fact.
So we are taking the RGB array. You have seen this image is colorful, so it is RGB image. So that's why we are taking this render mode equal RGB array.
So now what you are telling here 2 is there, here 3 is there. But both are all are different. This is what I want to confirm. We can plug these two. That one only I understand. Now I understand.
So might be some more extra values.
Maybe. So that's what I just want.
Because here I have checked the removing
The various
very
actions
Then you have to check like this. Then you tell
are
me that what
mentioned here. So environment dot step. We are just creating one environment where everything will be running. So the environment dot action space sample is the sample for random action from the environment section space. Here, environment step action executes the chosen action in the environment. So here we have observation, reward, terminated, and truncated, and info. This all are the actions we are mentioning in this game. So which will execute the chosen action in the environment. So the observation will be the new state after performing the action. Then the reward is the reward obtained for taking the action. Terminated is the if the episode means the game is over or not. So this it is mentioning. And truncated is that the due to time limit the actions have been cut. And the additional diagnostics information are also being used here as info. So all this we have to store all these frames for the animation. That's why we have put frame dot append, where the frame state, action, and reward are stored, which will be used and it will be shown in the image. But I have already shown you. So after that, approach plus equal 1. So here the step counter will be incremented by 1. So when it reaches 1000, then it will stop the loop, and, even if the game is not finished. So 1000 times it will be running for each step, and these steps will be random. So you have seen in this game, so the ball is moving, then it is going up and it is hitting the brick wall, and it might not hit the brick wall, then the ladder is moving from one place to another in the horizontal motion. So all these steps are done in this game. So these are done in the random way. Then we are just using one animation library, which is movie.editor. So this is basically for the video editing and animation creating, which the last the image will be created. And then we have to define a function to create the GIFs. So basically, the RGBA frames will extract the rendered frames from the frames display what we have already used in the above frame.append. Then the image sequence clip will create the video clips from the frames, and clip.write GIF will save the video clip as the GIF file, which is we saved in the last of the code. Animation.gif, it is creating and saving locally. Here in Google Colab, you can find it here in the files. This animation.gif, it will save locally. So if you are running in Jupyter Notebook, this will be somewhat we have to mention one specific path. There it will automatically save. Or where from where you are running the code, there it will be saved. So we can see this GIF file by using from IPython equal to. So this will display the save GIF image. You can see. So it's doing its job randomly. We have just mentioned the actions it has to take. So like that it will be going and it will end eventually. So this way we can implement the reinforcement learning. So it is basically used in game playing. I have already told you. So it is somewhat uh, advanced than the other algorithm. Most basic is the classifying algorithms. There we are just putting the data into levels as 0 and 1. So some criteria will be there. So based upon that criteria, if it criteria is fulfilled, then we will label it as 1. If the criteria is not met, then we will label it as 0. So based upon that, we will run the algorithm and we will get the model.
So there are multiple things.
So this way we can implement different algorithms for different type of data and different type of scenarios. So any doubt till now? So you can take n number of data sets and practice that way. So just we have to apply those algorithms into different kind of data sets. So Kaggle is good. You can take the data sets from there and practice and apply different types of algorithms. So that way we can implement the machine learning algorithms.
So if I tell something.
So this is the just way how we can implement for different types of data sets, and based upon the data sets we can apply the different types of algorithms. So do all just go through all the algorithms I have used and shown one by one so that you can get the better idea. So this way I have just shown you that how in different case of scenarios we can implement different types of machine learning algorithms. Only you have the data set and the type of data set you are having. So based upon that you have to apply the machine learning algorithm. Any doubt you can ask. Also you can ask in the chat in the group.
So now we'll first focus on this. If you have something reasonable from here, then we will try to see. Okay. Now my opportunity is to develop.
And we are also coming towards the end of this classes. So after that we will be giving you some assignments based upon whatever we have learned in these classes. So you just try to solve the assignment questions that I will share you after some time. And then at last we will conduct one test on the overall things what we have learned. So after that, we will finish this course for this year, and at last the certificates will be provided to you.
So we can try to check how much we are getting. So we can do this. I'll just try to see like whatever we are getting.
Okay, I will share. And this all the Python codes are very not very long scripts, small scripts, so you can learn easily. And learning the Python is itself a task. So these are implementing with various machine learning algorithms. So it will be somewhat similar. The dataset might change. So that way you can start your first uh, machine learning. Okay, then I will conclude here today, and I will share today's programs, whatever I've shown you. So you just try to do by yourself, then it will give you the better idea. And you just practice with different types of data sets. Okay, then I'm concluding here. Any doubt you can directly ask in the group also. You can put the question there.
Just sit.
Okay, then we will see in the next class.